So today, the web scraping project, what I did was on option pricing. So I web scraped yahoo.finance page, kind of easy website for me to scrape, I guess. The scope wasn't too big for this project. It was mainly kind of personal. I haven't done pricing for options about a couple years. I used to do this more frequently and a lot more math driven. So this is more a refreshing theme for me. So on this exercise, after scraping out the information I wanted, so the goal for this is to do two kind of basic method of option pricing. One is called a Binomial Tree, and the other one is called Monte Carlo simulation, which is just random simulation. Pretty easy. So the underlying index index is Russell 2000. I scraped out the information from December 1st, 2015 to May 20th, 2016, which is last Friday, market close. The option I have for this pricing exercise is a plain vanilla European call option, which is, so what you think about, just a little debrief on option. So option is more like gambling. So you're gamble on the stock, whether that stock will be that price, I don't know, a month from now on. So you don't get anything right now, but you might get something in the future. But this is it's one type of derivative. There are a lot of type of exotic options out there, which is very fun to explore. Whatever you want to do, there's a type of method that you can kind of bundle them together. So this is very straightforward. Now, first step, we're looking at the price of the underlying index. So we can see a market drop. The price dropped for this Russell 2000 in February of 2016 and slowly getting back up. So this is on the y-axis. Should have better labeled this, but on the y-axis, that's the price, the dollar amount. And then now we're looking at one thing for this is we need the daily volatility. I think Zach's first presentation on the data visualization was explore the volatility for the Black-Scholes model that he wanted to do. So for part of volatility is it's something that no one knows. So you're betting on the odds going up and down, up and down. So there are certain type of options or derivative that actually solely the underlying risk is the volatility. But for these kind of things where this is part of the underlying risk. So daily volatility is pretty much, you can see the line here, so you're taking the log of the next day's price divided by the previous day's price. So it's pretty much the growth rate and taking a log. So stock price is a random walk, so it's a stochastic process. That's part of the reason we're using a log normal here. I just kind of graphed out the up and down, the kind of the volatility, daily volatility on here. And now we're getting into the pricing part. These are some of the assumptions and parameters we're going to be using. So the exercise state is when you can kind of redeem this gamble bet. That is a month from now on, June 17th, and the exercise price is $980. And that's 29 days in the market. Underlying price is what we're closing as of last Friday if we want to buy this option. That is your market price at that point. It's $1,095. So expected volatility is actually the volatility here and annualized. Risk-free rate here is an estimate assumption set at 3%, which probably lower right now. So first method we're going to walk through is the binomial tree. So it's a tree, as we talk about today and yesterday, which basically the same thing as, so you start So now this is a tree of option price. If you think about the stock price, so you start today. Today is your stock price. What is the chance that the price going to go up? What's the chance the price going to go down? Up and down. That's how you construct your daily binomial tree. So the good thing about binomial tree is it actually gives you the flexibility if you want to construct anything. Say I want to exercise. If you're in an early exercise option, you can exercise earlier in the time period. You don't have to wait till the full expiration. So using the binomial tree, these are just some things that I probably won't get into the assumptions. U is up, D is down. P is the probability that this stock will go up. So that's the formula up there. And then after the tree, you get to your option price here. So for this option, exercise a month from now on at strike price of $980, your expected option price using the binomial tree method and all those assumptions I presented will be $117. And now we're using Monte Carlo simulation to kind of test out the payoff. So this is basically just a 0-1 standard normal distribution. You're kind of simulate, I think I simulated 10,000 or 100,000 iterations of this. Basically, you're kind of getting the Z number from the normal distribution. That is part of the input you want put in here on this formula. So ST is the stock price a month from now on. S0 is what you're standing right now. So you want to predict what it will be in the future, and then there's some up and down that was captured in the exponential term there. But that's basically how you construct the simulation. So after running 10,000 iterations, 10,000 simulated stock price. So I pull out number 50 to 80 just as a sample size for you guys to look at. So the stock price, which is 1,070 something right now, 30 days from now on, it could possibly be one of these numbers right there. So the payoff of the option is actually, for this call option, European call option, would be the difference between the strike price and the stock price at the exercise. So basically, that's the difference between that and the strike price of $980. So the payoff is what you would be making 30 days from now on at that date if you exercise. Now you want to discount, so there is another term called time value of money. So now you want to bring the future money dollar amount back to present. What you can do is you're just discount that money back. That is how you get to the call price. That is the average of all the simulation price of your iterated payoff, and then taking the mean of that number and then discount it back to nowadays, 30 days now, which give me $118 for this call option. So the two methods kind of give me very comparable, similar options right now. I think this option particular, the ask price in the market as of last Friday was 120. So it's somewhat there. So you kind of, the option pricing, it gives you a fair, what you believe is fair, because there are assumptions behind this and how you construct your model and what you believe in on the volatility side. That will give you a fair pricing that you believe in, and then use that number compared to what the market is showing right now. That could be your strategy of buying or selling at that point. That's it. Thanks. Questions? I'm sorry, I hope this is not too boring. I know this is, it's hard to kind of walk through everything within 10 minutes.
How accurate is your prediction after several months? You do some validation?
There's really no, you mean using which method? So if you're using binomial tree here, this is daily. So one period is a day. This is as of the 10th day. So if you want 6 months, you can literally have a tree that big. Those are at the end of the knot. Those are all your possible values. So the last one will be the possibility of going down 1 minus p to the power of 7 months. That will be, I don't know, 100 or 150 days, possibly at the end. So it's kind of the probability of up and down. So it's a binomial distribution. The m choose k, and then 1 minus p to the time of k. But it possibly, yes, it will give you a range from for 7 months out of there. But again, the range will be huge for you to kind of pick the middle point. So binomial tree is not widely used. It does more for presentation purpose. I feel like industry people use simulation more often. We don't really use binomial Black-Scholes formula because Black-Scholes is very theoretical. It doesn't give you the flexibility if you're constructing any type of option that you want exercise early or knock in, knock out, which is another type of bet. If during this 7 month of period the price drop to $500, then everything automatically happens. So you trigger everything to happen. So there's another trigger point you could include when you construct an option. Just another kick in the constructing an option product. It has a little bit. That's why people use Monte Carlo, because you actually see the number at the end of the stock price, and then you can kind of tweak your, let's say, trigger point, and then you can construct your payoff based on the different trigger point. But yeah, that's it's probably another semester of option pricing right there. Yeah. Yep.
I guess I'm confused. What data did you scrape?
I scraped Yahoo Finance, this Russell 2000 index from December 1, 2015 to that.
Maybe I should be familiar with that, but I'm not. So what was in there? What data was in there?
That is daily, the first column, so it's pretty much like a table. First column is your date, and then open price, closing price, high, low, volume, adjusted close. So those are like standard output of a, no, for this index. This is, so when you go to Yahoo Finance, you put in this Russell 2000 blah blah index, and you select the date that you want. It gives you this type of table. So it's like you're buying Apple stock. So you're buying Apple and you want to see Apple's past month of performance. So you put AAPL and you put last month of date. And that will give you the exact same column name, blah, 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 blah. Yep.
So who's in the Russell 2000 index?
Those are, help me, 2,000 companies, yeah.
Okay.
Yep.
So why don't you use a Monte Carlo simulation for a call option on Russell 2000? It seems like a pretty close form solution to the differential equation if it was neutral for that option.
Well, this is more, again, theoretically, if you're doing a plain vanilla type of option, you don't even need to use simulation. This is solely for the purpose of doing this presentation. My goal was actually doing another financial product was a bundle of Russell 2000, one of the other gold fund, and the other oil stuff. So those are 3 combined with a knock-in option. But that will be very hard for me to go through without anyone knowing the background. I
Where was the adding complexity? I missed that. I couldn't hear you.
add in complexity.
Yeah, where was the add? Yeah.
This is the simple version. I didn't say this is the add-in. So the Monte Carlo will give you the add-in if you want it, but then this is for a plain vanilla European call option that actually doesn't really need Monte Carlo to simulate, right? But I'm just demonstrating how to do it.
Yeah.
Well,
Did the binomial price of Monte Carlo simulation give you the same price?
Yes, 117, 118. Again, if you want any exotic things on top of a plain your option, you can always play with the Monte Carlo. That's something to add on. But if you don't do it in the first step, there's no place to add anything on. So you have to do the simulation first. Any other questions? Hey, no problem.